three-body problem specifically is this, and this is straight from Wikipedia, and I'll put up a graphical representation of what this looks like as well, because it's a mind bender. As we know, Newtonian physics is one of the basis of reality, I guess you could call it, right? In scientific terms, in many ways, not just the singular specific way of a body in rest stays in rest, a body in motion stays in motion. It gets larger and more wild and crazy than that, including, of course, up to this not just Newtonian physics in that sense, but then this let's say, I'll just read it. I'm butchering this terribly. In physics and classical mechanics, the three-body problem is the problem of taking the initial positions and velocities, or momenta, of three-point masses and solving for their subsequent motion according to Newton's laws of motion and Newton's law of universal gravitation. And that's the exact part I was looking for, Newton's law of universal gravitation. Unlike two-body problems, the three-body problem has no general closed-form solution. No actual closed-form solution. You can't mathematically model this easily and fix the thing. You say, look, this is what this will look like, okay? And I will put up the graphical representation in a moment because, look, I'm a visual learner myself, very spatially aware, I can see some of these things as they happen, sort of geometrically. I'm one of those guys. I'm more of a spatial awareness, what would you call it, geometry type in the way I learn, the way I see things, the way I see the world, right? There's 8 episodes. There's 8 full episodes, I believe, has the whole thing come out yet? I think they just drop it all, right? Yeah. Anyway, so back to this. So the resulting dynamical system of 3 bodies orbiting each other is chaotic for most initial conditions, and in most cases, the only way to determine their positions is to calculate them using numerical methods. Now, this is what it looks like. Back to that sort of, so basically we're talking about the orbital 3 bodies, okay? So 2 around each other is very easy to calculate because you only have the mass momentum of 2 things gravitationally interacting with each other, okay? Once you add a third to this becomes the foundational basis, can I say it properly? Foundational basis of chaos theory. Because you can't actually fix this, like I said, mathematically. Of course, we're talking about different mass objects, and there's all kinds of variables you could actually kind of toss in there. But that's the point of the actual calculations of this, is specifically if you have a situation going on where, you have 2 suns. Let's think Star Wars for a second, right? Tatooine. You guys all familiar with that? There's the 2 suns, and then there's the planet Tatooine that's, somehow in the binary solar system. Well, what does that look like in the 3-body problem? I don't know, because George Lucas didn't explain it, right? Except, well, maybe this stuff is happening out there and maybe it's not. I don't know. We have found some of these actual systems, but have we been able to model them? Because I got a feeling that nature has figured this out. Just we mathematically haven't perfectly kind of solved for this. I think that's part of the problem here. But anyway, so that's exactly the deal. Okay, and that's where we begin tonight, because this is the weird part of it, is when you look at this, you see what kind of a mess this becomes. A orbital, two points orbiting is really easy, okay? At least conceptually easy, not for the, math crippled mind like me. But geometrically, it's easy. It's one of those parts where you're like, okay, yeah, cool. This is fine. But then you add that third wild card into this, and the thing just spurgs out. It turns into this massive thing, even to the point where they might, at some point, reject the third body from the system and continue sort of with the dual orbit sort of situation, right? So I don't know. I don't know what this looks like in the longest term here, but and how this kind of works when you get really, really deep into the simulations and things like this. Because as you know, I'm not a scientist. I'm just me. I'm just little old me, just trying to wrap my mind around the universe and the multiverse as it is. So there's that, right? But then all the rest of this, that in this movie now, this Netflix series called The 3-Body Problem. There's it's specifically called it because of that exact system we're talking about, the 2 suns, a planet. And again, it's not to get too spoiler alerty, but it is a prominent part of the thing. And of course, chaos theory, which to me is probably, as amazing as it gets as far as a sort of conceptual thinking, because you can't really extrapolate that far out. Anyway, so that's what's going on tonight. Again, so beyond the 3-body problem is what I'm calling this, the dark chaotic forest hypothesis. We're going to get to that too. There's something called the dark forest hypothesis, all right, which fits perfectly into the 3-body problem, not just not the theory, but the Netflix show. And so the weird part about the show is it, just as a loose framework, spoiler alert, again, earmuffs if you don't want any spoilers whatsoever regarding the plot of this movie. But it's basically an alien contact movie, okay? But not just alien contact as you would expect. It's complicated, and which is right down our alley on Troubled Minds, because we always talk about what first contact might look like in that aspect, right? And so as part of that, there's some VR aspects of it, some weird maybe quantum internet things happening with maybe first contact. There's even some story of some backstory, some aliens in the past, and contact been happening for quite some time. There's a lot of really strangeness to this. And so this is probably a good time to introduce the idea of that dark forest hypothesis. Now, I threw chaotic in there, so it's not actually called the dark chaotic forest hypothesis. You know me and how I like to make up terms and mix ideas. It's called the dark forest hypothesis. So I'm going to pull this up and give you just a quick take on what this is. And you'll start to see what this means and how this starts to go, oh, okay, this gets weird. So the dark forest hypothesis, and this is real, this is a real thing, is the conjecture that many alien civilizations exist throughout the universe, but they are both silent and hostile, maintaining their undetectability for fear of being destroyed by another hostile and undetected civilization. It is one of the many possible explanations for the Fermi paradox, which contrasts the lack of contact with alien life with the potential for such contact. And we've talked about the Fermi paradox quite a lot. If there's aliens out there, mathematically, they should be every freaking place, but they're not. So what the hell? I mean, at least visibly, if you step out and stare into the sky, there's no cosmic highway and, roller coasters spinning across the sky. Obviously, I guess depends on who you ask, right? But so that's the weird part of this. You would expect a fledgling, let's say, technological civilization like Earth to have the thing going on where, like I said, the aliens are going to be like, these guys are, the first broadcast was like Hitler at the Olympics, right? Or the I Love Lucy, they were always talking about things like this. Like, this is the type of stuff that the aliens will find first from us because we're probably a very, very grotesquely noisy planet. Okay, assuming, they haven't been here all along, right? Depending on, again, ancient astronaut theorists say yes. But I mean, that becomes the weird part of this, because if we're broadcasting in that noisy planet space, why aren't we attracting a ton of attention? And you would expect that maybe we could be, okay? And so that dark forest hypothesis suggests that they're out there, they're aware of each other, where they're trying to find each other, but they're also not trying to sort of stir the cosmic hornet's nest and bring about an interstellar war, right? Which is why, I mean, absolutely wild to consider, and it's a very Troubled Mind style thought. But, as usual, it just depends on who you ask. Some people will be like, come on, Mike, there's no evidence for aliens, all the rest of the stuff, without drinking the maybe juice and stuff. But yeah, I don't know. It is incredibly strange that you consider that there is sort of a dark disquiet, I guess would be the term, for the cosmos itself. That's you would expect that these entities out there would be maybe more or less, obvious. I mean, I don't know. So anyway, so back to this real quick. So I'm going to read just a smidge of this, and we're going to have Doku join us in a moment here. So here you go. This is straight from the right up here, only because I don't want to get too far ahead before we get our guest in. So bear with me for just a moment here. So for millennia, humanity has gazed upon the night sky, its vast expanse of canvas painted with celestial bodies in an intricate dance. Yet beneath this alluring order lurks a potent undercurrent, the chaotic symphony of gravitational forces, which leads us to this the three body problem, right? So stellar explosions and cosmic collisions. This inherent wildness of the cosmos has captivated philosophers and scientists alike, sparking profound questions about the nature of reality and our place within it. Is the universe truly a chaotic mess, or does some underlying order orchestrate the seemingly random fluctuations? Here we, of course, we're going to delve into the cosmic chaos theory, which is one of my favorites. It is literally one of my favorite ideas. You notice I like to sprinkle chaos theory into these ideas because I think it is probably more prevalent than we allow for it in the models, because it doesn't fit in the models, because you can't extrapolate, as I described, so many years out. And these are those long cycles we talk about as well. So when you start to look at that and consider that maybe there's a ton of data that we would never be able to perceive without let's say, cosmic metadata, right? Like imagine, what's his name? Zuckerberg, right? That's the stuff he wants, like the cosmic metadata. He wants all the data in the cosmos, right? Like that's the type of stuff you would have to be able to extrapolate this. And then even, let's describe it in temporal terms, you would have to be able to kind of extrapolate out time as well. Because look, maybe you have the perfect conditions for some, I don't know, dare we say, I don't want to, put it out there as a something that happens in this space of, well, what would you call it? Like a cataclysm, like cataclysmic space. Okay. I don't want to put it out there and say the end is nigh, because it's not my style, right? As I've always said. But let's say that you had all the perfect ingredients, okay, for that catastrophic thing to happen. All right. Except maybe they didn't happen at the right time. So they were all there, ready to rock. The end was nigh. And then it came and went. And nothing happened at all. Okay. But, however, as part of that, maybe the end was nigh. Now we just have to wait like 20,000 years for it to happen. Right? Like maybe that celestial dance caused everything, put everything into motion to bring the end. Okay. And again, I'm not saying the end is nigh. Everybody relax. But you get what I mean. So if we don't have basically a time machine or enough data sets or enough foresight, this all seems like voodoo. It seems like cosmic voodoo at some point. And that's where this starts to get weird when you consider what the hell's really happening. So I don't know. No answers from me. You know the drill. But so what do you guys think? Have you seen this three-body problem? Like I said, if we can, let's keep the spoilers to a minimum, just because I know a lot of people haven't seen it, myself included, by the way. I did read the write-ups, like I said. So if you can, don't spill all the deets. But have you seen this? Are you interested? It seems to be, like I said, one of the hottest things out there recently anyway, which is pretty cool that there's still good stuff being produced, especially in the troubled minds style of ideas, right? I love that. But have you seen it? What did you think about it? And do you think that there is something to do, let's say something far more profound than we ever give credit to this idea of chaos theory? And not just a three-body problem, of course, but beyond that, what it looks like in both, not just, let's say, spatially, in the cosmos, but also temporally, and how deep does these or how long does this sort of long cycles actually happen? I don't know. No answers, as you know, just more ideas and questions here. But it is fascinating to consider that there are aliens out there, okay, and they are hiding. They're hiding because they don't want to alert other alien species, or what would you call them? Alien species, I guess would be the term. That they're there, because of course then you start to let them know you've got resources, you've got probably infrastructure, you've got a population to enslave in the ideas of the terrible old ways, and so it makes sense that you'd be hiding. And so this dark forest hypothesis does ring true to me, because I think if we were smart, we would have maybe shielded ourselves from that before we started broadcasting Hitler and I Love Lucy into the cosmos. But it's too late. So when we finally attract attention, direct attention, and they make themselves known, I think we might have a problem on our hands. Or maybe not. I don't know. That's the optimist in me. But maybe not, because, of course, no amount of optimism can bring or stop the end of times, right? So anyway, but wild stuff here. So three-body problem, it is a mathematical sort of philosophical, can I say it, construct. And it is one of those things that really spawns the whole idea of chaos theory, which, like I said, I really, really, really love. And as part of it, you guys tell me, is this chaos theory cool? Not, otherwise, is it you think it's just a philosophical construct that doesn't play as much as it should or couldn't, or vice versa, or upside down? As usual, you know me and the ideas. I don't really know those answers, but I do know that real quick on this, there's an article that came out from New Scientist, and this is absolutely wild to me, and this is exactly very troubled mindsy, which is why I love the newscientist.com, the website here. But check this out. Why we need to invoke philosophy to judge bizarre concepts in science. And there you go. That's kind of at the heart of what we do all the time. It's kind of looking at things, squinting at the science, and then philosophically wondering what will come next as part of this, right? So just a little bit from this, and then, what, really? It's going to make me sign in. All right, I'll sign in a sec. But it isn't easy to predict where the next leap in scientific understanding will come from. Indeed, ideas that in hindsight mark obvious paradigm shifts can first make you feel quite unsteady on your intellectual feet. So as scientists poke around for new ways to understand the universe, how seriously should we take these embryonic revolutions? And that means time-wise, right? So they talk about it on this article. I'll sign in and do all the rest of that momentarily here. But yeah, the wild stuff, because I think this is exactly the point of all of this. We always talk about informing our ideas, informing tomorrow's science, because you got to put them out there first. Somebody has to believe that something is possible, like a quantum internet, or being able to create the unhackable communication, which we're told is happening currently. But if nobody dreamed of it then, do you think it would be possible now? Becomes one of the questions as part of this, right? I don't really know. No answers. You know me. And all the disclaimers apply, by the way, as well. We're not here telling anybody the truth of anything, just kind of throwing wacky ideas out and wondering if maybe something will stick, and maybe possibly even start encouraging the next generation to start doing these maybe scientific things that seem absolutely wild and wacky, but instead there's something quite a bit more pertinent and on point. So I don't know. You tell me. As always, I'd love to hear your thoughts on this tonight. We're going to get Doku in here in a moment as well. He said he'll be right there. So that's that. That puts us about where we need to be. We're talking the three-body problem tonight. Not just the three-body problem, but how it spawns chaos theory, and chaos theory extrapolating out into the cosmos. I think it's very possible that this actual notion of chaos may be the backbone of everything. Literally everything. Except it's unquantifiable in the largest sense. You get it? I don't know. Maybe, maybe not. Today we're talking about the three-body problem and how it spawns the idea of chaos theory and extrapolating cosmically and temporally how weird and how wild does chaos theory get. Is it possible that it's one of the driving forces of evolution in the known cosmos? The known multiverse, as we say. And even does it extend past sort of the veil, past the let's say not just universal space, but into the multiversal space. That's how this stuff gets starts messing with my mind when I start thinking larger and larger, right? You're like, okay, it's easy conceptually, but then once you start not knowing all the details, very chaos theory-esque, then we have problems, because without knowing all the details, it's, kind of a thumbnail sketch at some point. You're just like, yeah, it's about, maybe like that. And it's very trouble-mindsy, right? Which is good. It's fine. Except I think when you start to look at what this may have been sort of a driving force in the cosmos, it brings us back to what we were talking a little bit about last night. What I've talked about at length in the past is that whole, grand architect and the dark counterplayer of Philip K. Dick. I was talking a little bit about that last night with the folks when we were doing the roundup there together. And so basically it's just, we have this duality of creation, which we've always talked about often on the show. Maybe not recently, but definitely we've kind of put that idea through its paces, meaning that we have at its most fundamental basis order and chaos sort of working in tandem, and maybe even very much like this three-body problem as part of the aspect of it, and how these things do come together and maybe create, I don't know, like how would you describe it? Let me think. Let me put my mind to the test here, make up a new term to maybe explain this idea. Something like I don't know. So if you take order, you take chaos, and it creates maybe like a super order. Okay, you see what I mean? Maybe like a super structured order of the aspects of these two things coming together, and then looking at this in the long sense that maybe it's not as chaotic as we would think, because there's still the two things kind of coming into contact with each other and, bouncing off of each other. And even in, some of these simulations of the three-body problem, even the third party being ejected entirely out into the cosmos. So I don't know, maybe like a super order of sorts, but you have to be able to sprinkle in and account for all the chaos theory that kind of comes with it. And that's the weird part of this, and why it always draws me in. But yeah, back to this real quick. Oh, I didn't actually sign in. Oops, sorry about that. That was rolling away for a snack. And yeah, let's see. Hold on. And we'll go back to this. So why we need to invoke actual philosophy to work with some of the most bizarre concepts in science is really what this is about. It's again, I'm not a scientist, as you know, and this whole thing kind of comes into play because we're dealing with data sets that are unfathomable, to be perfectly honest. They're just way too big. Well, as of yet, I guess maybe when we get to the AI kind of gobbling in cosmic data sets, imagine that, gobbling in actual, like everything that let's say our astronomers or our telescopes or whatever have ever gobbled in, even going back in time, sort of looking at some of the old Assyrian tablets and things like this. and finding some of the actual cosmic, what would you call it, the depictions they made, sort of in clay tablets. I wonder if at some point you're able to feed all that stuff into a massive AI superstructure of sorts, the AGI or something to that effect, that it's going to be able to start doing what? Like predicting this maybe super order, as I'm describing it, this higher structured order. I don't know. Anyway, back to this. Now, this is pretty wild stuff. So take supersymmetry. This is from that New Scientist article, right? So why we need to invoke philosophy to judge bizarre concepts in science. And we'll get back to the three-body problem in a minute here. This kind of is one of those points that points right back at it. So take supersymmetry, the much beloved by physicists, at least, notion that every fundamental particle we know of has a much heavier partner than that we are yet to discover. Seems voodoo, right? Seems like something that is or isn't as you would expect it to be, because we're like, well, it must exist. We just don't know where to find it or any of the rest of that, right? So it's mathematical elegance sends proponents into rapture, but it is let down by the small matter of us not having a shred of evidence that it's true. No, philosophical constructs, as I always say, right? So in that sense, take dark matter. Dark matter at first appears on firmer ground, they say. Under our current best understanding of gravity, Albert Einstein's general theory of relativity, various lines of evidence point us toward the idea that 85% of the mass within the universe is visible. We see its gravitational effects throughout the cosmos, and yet dark matter feels a bit too convenient. Yes, it explains a bunch of otherwise unexplainable phenomena, but given that we are yet to directly detect a particle of dark matter, that explanation feels uncomfortably like writing "Here be dragons" in the margins of cosmology. Why not? Hey, why not? Look, clearly I've been writing "Here be dragons" in the annals of cosmology, at least troubled mind style, for quite a while now. So that to me doesn't seem too ridiculous. Okay, so in that sense, I don't know. So anyway, we're talking the three-body problem tonight. See what I did there? Suddenly, three-body problem becomes the eight-body problem, becomes the 8 body problem, and then suddenly we're way off the beaten path. Anyway, so we got Doku coming on in a minute. He just popped in here, so we'll get him on and taking your calls as well. What do you guys think about this? Have you seen this three-body problem on Netflix? Are you familiar with the philosophical construct of the actual three bodies and let's say gravitational aspect, and does this creep you out? And we'll get into the dark forest theory as well, with these maybe alien civilizations hiding from us and hiding from each other, because of course, if you let the other, let's say, predators of the cosmos know you're there, they're going to come get you, right? I don't know.